Hello friends, today we'll know the moment of inertia. Before we know the moment of inertia, let's go with the theorem. Okay, this is a theorem of perpendicular acid. Ix is equal to Iz plus Iy, and theorem parallel axis is Ic plus mh square. So this is a parallel axis theorem. This is a perpendicular axis theorem. So move to the moment of inertia. Okay, so this is like moment of inertia of a ring. Okay, so moment of inertia of a ring will, when we're finding the moment of inertia ring, so we'll take a axis. Okay, axis which is passing through the center and which is perpendicular to the its length. So it is from z to z dash, and its moment of inertia is what, mr square. Okay, mr square. When we're taking about to diameter, like diameter is what, like x to xz and y to z is diameter. So we're taking an axis. This would be our axis, z to z, and we have to apply this theorem. Like this is what, this is like perpendicular theorem. Okay, perpendicular theorem. From perpendicular theorem, we have this formula, and here we know that this diameter is equal to this diameter. Okay, this is the diameter, so it will be the id, and 2id equal to mr square. We previously have the mr square. This is the Iz. Okay, this is nothing, just Iz, and when you're putting out, you will get the about diameter, what is the moment of inertia at diameter. Okay, that's it. Now this is also a ring, but here we are taking an imaginary axis which is passing through its end. Okay, and which is parallel, which is parallel to the diameter. When it is parallel to the diameter, we are applying the theorem. The theorem is parallel axis. Theorem of parallel axis. Okay, parallel axis. So this is the theorem of parallel axis. As I told you that this gonna be the moment of inertia, and this would be the mr square. Okay, and here is like we're taking the diameters, about diameters moment of inertia, and adding mr square. Okay, that's why it's 3/2 mr square. When we add 2, we'll get this. Okay, and here now is when we considering about its tangential and parallel to the axis. Okay, it is tangential and parallel to the axis, but this time which is parallel to the diameter. Okay, so it would be this. Okay, it would be this, and it has like Iz plus imr square. So we had the Iz is like mr square. Wait, here is like mr square. So we add the mr square and mr square. Here is the theorem which applied, theorem of parallel axis. Okay, here is like the theorem of parallel axis. Okay, now so move to the ring. Okay, before move to the ring, move to the disc. So this is a disc. Okay, and this disc has like axis which passes the center and perpendicular to this plane. So it has half mr square, and we have to do the similar to the what we did in circular ring. Okay, about the diameter, we'll add id plus id will be 2id, and it will become mr square by 4. And now this is like tangential and parallel to the diameter. Okay, tangential and parallel to the diameter, so it will be the mr square. And here we'll applying the wait a second, this is not this was for the ring, this is for the disc. Okay, so tangential and parallel to the diameter. Okay, so this would be what, we know the diameter, this is for the id, and this we are applying the parallel theorem here. So it will be the mr square and mr square by 4. It will be the 5 by 4 by mr square. And here about an axis tangents to the disc and perpendicular to the plane. So if I in previous video I talked about this. Okay, so this is also would be the tangential. Not in previous video I talked about in that video, but a different topic. So this is like tangential to the disc, tangential to the ring. Okay, this is the ring one, and perpendicular to the plane. Okay, this is like a tangential to the ring and perpendicular to the plane. So this is not, this is what it exactly to look like. So it is perpendicular to the plane. Okay, perpendicular to the plane, and sorry, tangential to the ring and perpendicular to the plane. So it would be mr square plus mr square. It will be the 2mr square. Okay, it was for the ring. Okay, but now we are dealing about the it is for the disc. So it was a mistake, so I did it correct. So for about an axis tangential to the disc and perpendicular to the plane, so it would be like this would be the id, no, this would be the iz. Okay, iz. Okay, what you find in the from, let me check from, not here, actually I missed one of this page. So like this is like iz we had to know, which is like the fundamental. If this is a disc and passing through, it has a moment of inertia mr square by 2. So that is like mr square here, and this is mr square. This is by a parallel theorem. Okay, we get 3 by 2 mr square. Okay, that's it. And now we'll discuss about some moment of inertia of solid cylinder. Solid cylinder has I half, it's about axis, it's I equal to a half mr square. Okay, when it's about the center, center we have the ml square by 3, like we know from the rod. Like if we take it from the end, we have the ml square by 3, and here is like you have to take the mr square by 2. Okay, mr square by 4. Okay, this is 4. So that's it. And for hollow sphere it would be 2 by 3 mr square, and for solid sphere it would be 2 by 5 mr square. And for a rectangular body, we know that from a thin body which is ml square by 12, it is kind of the similar. Okay, when you consider it, it's kind of the similar, m by 12, and l square is what here, n square will be become a, this is rectangular a b, so a square plus b square. That's it. That's it. That's okay.